Okay, we're going to take a look at these simple math functions first. These are relatively straightforward, so it shouldn't take too long to go over them. The first one was write a function called miles to feet, which would accept a number of miles, return the number of feet. Well, there's 5,280 feet in every mile, so if it's 1 mile, I want to return 5,280. If it's 2 miles, I want to return 2 times 5,280. And I want to take the number of miles, multiply by 5,280, and return that answer. Just a couple of things, this is really straightforward, but it's always good to write descriptive variable names. If you use descriptive variable names, it will make it easier for you to understand what you're doing, which is always a plus. And always initialize your variables. If you initialize them, you're telling the Python editor what data type it is, and that will come in handy, not so much for numbers, but when you're doing things like strings and lists and dictionaries. When you hit the dot key after one of those variable names, if the editor knows what data type it is, then it will come up with a list of the methods that belong to that data type, and it'll make your life a lot easier. Another thing, we could have done something here, put in like another line where, you do feet equals miles times 5,280, and then down here you just return feet. It's fine. It just requires an extra variable and one extra step. I just assume, cut out the middleman here and just put a return statement up here and be done with it. The next one is converting hours, minutes, and seconds to a number of seconds. And we're going to pass in hours, we're going to pass in minutes and seconds. And we know there are 3,600 seconds in an hour, so we have to multiply those two together. We know there are 60 seconds in a minute, multiply those two together. Add on the number of add on the number of seconds in an hour, add on the number of seconds in the minutes, add on the number of seconds, and return the sum of those three numbers. Number 3, we want to determine the perimeter of a rectangle, which is the length plus the width plus the length plus the width, just going all the way around the outside. And it's good, so that's the length times 2 plus the width times 2, and that's all there is to that one. Number 4 was to determine the area of a rectangle, and that is just the length times the width. So multiply those together and return. Number 5 was to find the circumference of a circle when given the radius. So call your argument radius. And frequently when you deal with some of these circle functions, you see r instead of radius. You can do that if you want to, but radius is more descriptive. And I would much prefer have something that's a little bit easier to read. Most people might be able to guess that that's the radius, but if you spell it out, there's no doubt. So the formula for circumference is to take the radius times 2 and multiply by pi. And so that is our formula here, and that's all there is to that one. Number 6, we want to find the area of a circle, and that is the pi times the radius squared. And you can, I told you, use 3.14159. On the one up here, I use math.py. Now, you can only do that if you import the math library. So let's go back down here to where we were. So on this one, I used pi from the math library, and that has more digits of precision than just the 5 digits that I gave you. Either one is acceptable as far as I'm concerned for this assignment. So we pass in the radius. It's going to be pi times the radius squared. We could have done radius times radius here, but since Python has an exponentiation operator, it's simpler to write it like that. Number 7 was future value. We're passed in a principal, a rate, and number of years. And the rate is passed in basically as a whole number rather than as a percentage. So if it was 5%, we pass in 5. Which means we've got to divide it by 100 down here to make it into a percent. So when you're calling this function, you have to know that this number is supposed to be 5 for 5%, not 0.05. Otherwise, you'll end up dividing that by 100, and your answer will be way off. So this little formula here just takes the rate and adds it on. So if we're doing 5%, it'd be 1 plus 0.05 or 1.05. And if I multiply that by, or raise that to the number of years power, then what this is basically computing is compound interest on $1. So here's my $1, plus the interest for that many years. And so this formula right here tells me how much I'm going to get for $1 if it's invested. And then if I multiply that by the number of dollars, that will give me my answer. Down here on number 8, it's the distance. We want to find the distance between 2 points, where the first one is x0 and y0. The second one is x1 and y1. This is basically the Pythagorean Theorem. And we want to find out how far we're moving along the x-axis horizontally, how far we're moving up and down, and those are going to be the 2 legs of our right triangle, and the distance is going to be the hypotenuse. So the Pythagorean Theorem says take these two and find the difference. It doesn't matter which one we do because we're going to square it, which will always give us a positive number. Do the same thing for y, and we'll square that. Add them together and take the square root, which is in the math library. So if we run this, which I just did a little bit ago, let me see. I've got a bunch of stuff to scroll over here before I actually get to the function call. So here is the code to test those first 8 functions. I just copied this from the problem description in the Word document. And so I'm telling what the answer should be, and then I'm comparing that with the actual answer down here. And this is where I used more digits for pi. This is where I used fewer digits for pi. And this one down here is a little funny. It should be like $1,610.51. We get this number that's way out here on the end, which is basically insignificant. So that would round off to 51 cents. And the reason for this has to do with the way that fractions, real numbers, are represented in a computer. And the problem with real numbers in a computer is that they are always, not always, but most of the time, they are approximations of the actual fraction. And so we're always going to be off, you know, usually out there around the 15th decimal place. We may be off by a little bit. But we're not going to worry about that in this class. And then we're trying to find the distance. And if you look at this, this is going from the origin and then going over 4 and up 3. And you may recognize that as being a 3, 4, 5 right triangle. So if the legs are 3 and 4, then the hypotenuse is going to be 5, and that is what we get for an answer. And we will continue with the other functions in the next video.